Now let us draw a 4-point linear transformation matrix. So for a 4-point linear transformation matrix, the output will have 4 number of samples and the input will also have the 4 number of samples. So output we can write like this: capital X of 0, capital X of 1, capital X of 2, capital X of 3 is equal to, this is my W matrix and this is my input, small x of 0, small x of 1, small x of 2, small x of 3. Now let us fill this W matrix. So as we know, the first row and first column has W to the power 0. As we are calculating 4-point DFT, so the subscript will be 4, W4 to the power 0, W4 to the power 0, W4 to the power 0, W4 to the power 0. This will be W4 to the power 0, W4 to the power 0, W4 to the power 0. Now the second row will be W4 to the power 1, W4 to the power 2, W4 to the power 3, or you can see the multiplication table of 1, 0, 1, 2, 3. Then it will be multiplication table of 2, W4 to the power 2, W4 to the power 4, W4 to the power 6. Next is W4 to the power 3, W4 to the power 6, W4 to the power 9. So this is the W matrix or the linear transformation matrix of a 4-point DFT. Let us further simplify this particular matrix and we get capital X of 0, capital X of 1, capital X of 2, capital X of 3 is equal to, as W4 to the power 0, anything to the power 0 is always equal to 1. So we can write here 1, 1, 1, 1, 1, 1, 1. And this is W4 to the power 1, W4 to the power 2, W4 to the power 3, W4 to the power 2, W4 to the power 3, W4 to the power 4, W4 to the power 6, W4 to the power 6, W4 to the power 9. And this is my input: X of 0, X of 1, X of 2, X of 3. Now let us calculate the values of W4 to the power 1, W4 to the power 2, W4 to the power 3, W4 to the power 4, W4 to the power 6, W4 to the power 9. So as we know that W4 is basically e to the power minus j 2 pi upon capital N. And as the length of the sequence is 4, we can write e to the power minus j 2 pi upon 4, which is e to the power minus j pi by 2. So the first value is W4 to the power 1. So we can write e to the power minus j pi by 2 to the power 1, which is again e to the power minus j pi by 2, which can be written as cos pi by 2 minus j sin pi by 2. So cos pi by 2 is 0 minus j sin pi by 2 is 1. So the result is minus j. Now let us calculate W4 to the power 2. W4 to the power 2 can be calculated in two ways. The first is W4 to the power 2 can be written as W4 to the power 1 dot W4 to the power 1. As W4 to the power 1 we already calculated is minus j into minus j. It will be j square and j square is minus 1. So this is first method. Otherwise we can go for the conventional method. W4 to the power 2 is equal to e to the power minus j pi by 2 square, which is e to the power minus j pi, which is equal to cos pi minus j sin pi. Cos pi is minus 1 and j sin pi is 0, so my result is minus 1. So in either of two ways we can calculate the value of W4 to the power 2. Next we will calculate the value of W4 to the power 3. So again W4 to the power 3 can be calculated by W4 to the power 1 whole to the power 3. As W4 to the power 1 we have already calculated, which is minus j whole to the power 3. So minus j cube is equal to j. First method. Now we can also calculate the value of W4 to the power 3 as W4 to the power 2 dot W4 to the power 1. W4 to the power 2 is minus 1 and W4 to the power 1 is minus j, which is equal to plus j. Or we can also calculate the value by W4 to the power 3 is equal to e to the power minus j pi by 2 whole to the power 3, which is e to the power minus j 3 pi by 2, which is cos 3 pi by 2 minus j sin 3 pi by 2. And cos 3 pi by 2 is 0, whereas j sin 3 pi by 2 is minus 1, which is plus j. Next we will calculate W4 to the power 4. So W4 to the power 4 can be calculated by W4 to the power 2 dot W4 to the power 2. W4 to the power 2 is minus 1, so the result is 1. Next is W4 to the power 6. So W4 to the power 6 can be calculated by W4 to the power 3 to the power 2, and W4 to the power 3 is j square. J square is minus 1. Finally we will calculate W4 to the power 9. W4 to the power 9 can be calculated by W4 to the power 3 to the power 3, and W4 to the power 3 is plus j to the power 3, which is minus j. We finally calculated all the values for the total factor for the matrix. Now let us put these values on the matrix. This is capital X of 0, capital X of 1, capital X of 2, capital X of 3, my output matrix. This is my W matrix, and this is my input, small x of 0, small x of 1, small x of 2, small x of 3. So the first row and first column is 1. Next is W4 to the power 1 is minus j, W4 to the power 2 is minus 1, W4 to the power 3 is plus j. Next, W4 to the power 2 is again minus 1, W4 to the power 4 is 1, and W4 to the power 6 is minus 1. The last row is W4 to the power 3, which is plus j, W4 to the power 6, which is minus 1, and W4 to the power 9, which is minus j. So this is my complete linear transformation matrix for the calculation of DFT. Now if we need to calculate the DFT of any discrete time sequence, we can put that discrete time sequence here and we can easily compute the value of DFT.